Hey all, today we're going to continue talking about functions, and today we are going to introduce the idea of domain and range of function, which are two ways to describe how far a function goes. So we've looked at tables and related them to functions, and let's talk first about the domain. The domain of the function is all of the x values. So we can write a set of all of the x values. So in this table, we can look at all the x values and we write them in set notation with the little curly braces. And we typically list them in order from smallest to biggest. And if we have a repeat value, then we don't repeat it. We just write it once. So our x's, and this is actually not a function, it's a relation, because this value 2 goes to two different y values, but we can still write the domain of this relation, all the x values. So -4, 1, 2, and 6. We don't write the 2 twice, even though it appears twice. The range is all of the y values. So if we want to write the range, we're going to write it in set notation. And we typically, again, will write it in order. So we have 0, we have 2, we have 3. That shows up twice. We'll write it once. And we have 6. So we have a list of all the possible x values. That's the domain. And a list of all the possible y values. That's the range. And so anytime we want to know the domain and range of a relation or a function, no matter which way we represent that relation or function, so we use a table, or in this case, a mapping, or if we have just a set of points or coordinates, or if we have a graph, we're just writing down the list of all the possible x values that's contained in that relation or function. So here we do have a function, because all the x values only go to one y value. The domain are all the x values. That's these ones right here. These are the y's. And we'll list them from smallest to biggest. In this case, -7 is the smallest. It's the most negative. And they're listed in order. That's my domain. My range is going to be my y's, and I'll color code. And it's just, you might think we're just rewriting all the numbers that are there. But like we saw on the last one, sometimes those numbers are repeated. And so we want to make sure we know that it only shows up once in the domain or once in the range, even if it's a repeated value. Remember that when we look at coordinates, the first number is an x value. So all these first numbers, they're x's. They're going to make up our domain. The domain is the set of all of the possible x values. They're listed again in numerical order. And I keep writing irregular parentheses. My range is all the y values. Y values are always the second number in the coordinates. Ooh, I'm going to list them in order, so I'm going to put -6. And there we have the domain and range for given coordinates. So all these different ways we can show a relation or a function, we can pick out the domain and range. And this is going to become a little more meaningful when we look at graphs. Maybe a little trickier when we look at graphs too, because we got to remember how to pick out what is what. So remember that going from left to right gives me an x value, and we always start at this point in the middle called the origin. And the x value is going to tell us how far to the left or right we went to get to that point. And so if I look at this first point, I had to go 0 to the left or right. This point, I had to go 1 to the right. This point over here, I had to go 4 and 6. And for this one down at the bottom, I had to go 3 to the right. Of course, to the left is negative. When I look at the y's, it's how far did I go up or down. So for this first point, I had to go up 6. And here I went up 5. I didn't mean to put a parentheses there. And here I went up 7 and 7. And over here I went down, so that's -7. And so now that I have all of those values, I can list the domain. My domain is 0, 1, 3, 4, and 6. And my range is -7, 5, 6, and 7. And we will not write the 7 twice, even though it shows up more than once, we'll only write it once. If you struggle picking out what are the x and y values off of the coordinate plane, please do ask me for help so we can talk about it together. This is something that hopefully you have done in the past, but could be a little tricky trying to remember. And we won't always just see points in the coordinate plane. Sometimes we're going to see lines or curves or different types of shapes in the coordinate plane. And we can write a domain and range for those, but we're going to write them in a little bit of a different way because whenever we have a line, it contains a lot of points, and we're not going to be able to pick out every possible x or y value. And so we'll write that in form of an inequality. So I'm looking to write the domain of my graph on the left here, where it has 2 blue dots, one on each end. I'm going to find the x value of the first dot over here. The x value is -6. I had to go 6 to the left. And for my other dot, I had to go to the right 6. So +6. And my y values, I'm going to find out the lowest point that this thing goes, which is actually this same point over here. The lowest point would be 0 up and down. And then my highest point looks like it's right here, which is 4 high. And I'm going to use these numbers to construct my domain and range. So my domain is going to tell me all the possible x values that are contained on this line. So all the points and all the x values that they might have. Well, my smallest x value in my domain is going to be -6. And the biggest x value is going to be +6. Because -6 is the furthest it goes to the left, +6 is the furthest it goes to the right. And so all of my x values are going to be either equal to those because they're solid dots. As you can see over here, we have some open dots. The solid dot means that value is included. The open dot means it's not included. So my x values can be equal to -6 or greater, and they have to be smaller than +6 or equal. So x is between -6 and 6, so that's why we write those inequalities. But it can also be equal to those, so that's why we give them the little lines underneath. My range, I'm going to do in a similar way. The lowest that my curve goes is 0, and the highest it goes is 4. And so all my y values are going to be between there. And so I'll just put the inequalities like that. And since they're closed dots, we're going to put the little equals to as well, because I have a point that has a y value of 4, and I have a point that has a y value of 0. But all the other points on this blue curve have to have a y value that is below 4 or above 0. And when I look at one, like I said over here, we can do the same thing. The only difference is when you have an open dot there, that means that those points are not included. We're looking only now at the blue curve and not those points on the end. So when I look at my domain, the furthest my curve goes to the left is 1. The furthest it goes to the right is 2. I'm going to put my inequalities the same way every time. I have a point here that has an x value of 2, so I can put my little equals to underneath. But my points that have x values of 1 are open circles, so I'm not going to put the little line underneath the inequality between 1 and x. And then I'll look at my range. And you can actually start this way every time if you want to. We need to determine the numbers on each end and then whether or not we put a little line underneath the inequalities. We're not going to be putting lines underneath these inequalities because they're open circles. The highest this thing goes is 4, but since it's open, that means all the values need to be below 4, and they need to be above -4. So this says that all my points have y values above -4 and below +4. As always, if you need some help before you go do a couple on your own, please do ask, because right now I'm going to ask you to try a few on your own. I have 3 here I want you to try, and then I'll show you the answers. And then I have a couple more I want you to try. I'll show you the answers. If at any point you get any of them wrong, make sure you ask if you can't figure out your mistake. Pause the video right now and try these 3. It's okay if you make a mistake, but please do try them on your own. So hopefully you got these answers. If you didn't, please see if you can find your mistake. If you can't, have me come over and I will help you find your mistake. I have 2 more I want you to try before you get into the practice. I want you to find the domain and range of each of these graphs. Pause the video here and try this on your own, please, and then press play for the answers. So the second one, let me talk about specifically because it looks a little different than the examples, but it's the same idea. You can see that the range for all of the options is called all real numbers, and that's because these arrows mean that this line is going to go on and on forever down and on forever up. That means there's always going to be a point on that line that has any y value you can pick. So whenever we have the lines that go with the arrows on the end that go up all the way and down all the way, our values are going to be all real numbers. That means any real number we pick will have a point on there with that y value. When we look at our domain, if we start this way every time, we can see that we only go over this far to the right, which is 1. So we don't have any x values that are bigger than 1. And since there's an actual point there, we can put the little line underneath, equals to. We have a point on this line that has an x value of 1. But then again, this thing is going to keep going to the left forever and ever. As it goes down, it's going to keep going to the left. As it goes up, it's going to keep going to the left. And so there is no number to put here because it's going to keep going. So that means all of our x values are either equal to 1 or less than 1. And that's as far as we go. And you might recognize, hopefully, that this is a relation and not a function because we have some points that have the same x value. So I have 20 practice problems, some of each type. Please let me know if you have questions. Please, if a box turns red because you got one wrong, raise your hand and sort that out before you move on to the next one. Let's make sure that we don't practice using the same mistake multiple times. Take your time on these. If you need help, ask, and good luck. Sorry about the screen size.